video, we are going to discuss about the static analysis for seismic analysis. So here I am going to choose the structure by Run Structure Wizard. So here we are going to select the frame models and just go for bay frame. And I am going to take the length as 20 and height also 20. And similarly width is something around 16 here. And for width I want to go for 4 divisions and height I want to go for 6 divisions. And here 20 by 6 it gives some other value like 3.33. So I want to divide it for first one is 4 here. So just you can highlight and delete that one 4. Next one is 3.2, 3.2, 3.2, 3.2 and again last one is also 3.2. So there are 5 floors of 3.2, okay, and this rises to 16 plus 4 equal to 20, okay. So click on OK here and width is also 4. So click on apply and we are going to get this structure. Close this one and would you like to transfer? Yes and OK. So you can turn off this grid mode here. Next step we need to assign the properties. So just go for define. And for properties of column, I want to define as 0.45 cross 0.45 for all the members. In general, practically you need to give as per the requirement. So for understanding purpose, I'm just going to take 0.45 cross 0.45 for the column. And for beam, it is 0.3 cross 0.23. And click on add and close. So let us go for 0.45 cross 0.45 and just go for the select menu. Beams parallel to Y and assign to selected beams, assign and yes. And similarly we need to choose the second property and go for select beams parallel to Y and we'll go for inverse selection. So by inverse beam selection and assign to selected beams, assign yes. So we have defined the properties and next step is to define the support conditions. So we have to create the fixed support and just select the support 2 and assign it for all the bottom nodes. Assign to selected nodes, assign and yes. Next step we need to define the load cases. So here first of all we need to define the seismic. Okay, we have to give that in the seismic definition. For seismic definition we have to follow IS 1893. So click on this and here under type we are going to get the loads. Choose IS 1893 2002 or 2005. Click on generate here. So we are going to get another window like this. Either if you know the city, you can just select from the list available here, or else if you know the zone for that particular structure where it is located, then you can go for directly zone. And for seismic, we are going to have the 4 zones 2, 3, 4, 5, and according to the different zones, the Z value will be differing here. Okay, so whatever value you need, directly you can go for zone, or you can simply select the city from the list. So right now I'm just going for zone and I'm going to select something around zone 4 and here we are going to have the response reduction and here special RC resisting moment is there. Okay, so right now we are going to consider that as the RC moment resisting frame here. And importance factor, so it totally depends upon the type of structure. Okay, usage of structure, like it is a normal residential building or a commercial building, okay, like hospitals etc., that comes under important building, right? So as per that you have to select the importance factor there. So I am going to select it as a general building and you have to give the parameter like soil type. We are going to select it as medium soil and structure type depending upon material. If you are taking steel structure, you can go for steel frame, and if it is a RC frame, you can simply select RC frame and give the damping ratio as 0 to get the accurate results. If you knew the foundation depth, how much you want to give there, you can assign it there. And if you want to give the time period, you have to calculate with respect to IS 1893 and you have to use the time period formulas which are available in the code. Right now I won't give any one of these things. STAAD will automatically calculate the time period depending upon the given parameters and given structural parameters there. So click on generate and click on add. Okay, so this definition has been added and we have to give the loads that are coming on the building or the structure so that these all loads can be taken under the definition. So I want to assign directly the floor loads, 2 dead loads, one dead load and another one is live loads. So I'm just going to take -5 for dead load. So just starting from the height 4, maximum height is 20 here. Okay, if you want to add for different floors, you can add the different pressure values. For example, for floors and for roofs it is different, you can give that one. So here I have taken 4 and 20. So click on add. And similarly, if the live load is somewhere around 6 kilonewton per meter square, for seismic analysis, we have to take only 50% of the live load. Okay. So if I want to give 6 kilonewton per meter square as the live load, I have to take 50% of that 6 kilonewton per meter square. So that equal to -3. -3 kilonewton per meter square for 4 and 20 meter height. If I want to define for different floors, you can define it. Right now I want to define for floors 1, 2, 3, 4, 5 floors. So you have to minus 20 minus 3.2 and you have to give this height. Otherwise simply you can calculate from here to here. So this is 16.8. You can check that in 3D also. So that is 16.8. And for roof, we are going to take other value. For roof, let us consider it as 3 kilonewton per meter square. So half of or 50% of 3 kilonewton will be minus 1.5 kilonewton per meter square. So that leads to Y range of 20 and 20. So click on add and you can close this one. So this is dead load. As it is, whatever the value we have to assign there. And second one is these two are live loads. Okay, and for live load, which we are going to define in the seismic definition, we have to take 50%. So we have defined half of the pressure values there. And next step, we need to create the load case details here. So just go for load case details. In static analysis, the important step is we need to create the seismic cases first. Okay, you can just give the name like EQX, EQ minus X, like that, whatever the direction you want to define there. So click on add, and similarly I want to add EQZ also. So naming, you can give any title name there as per your consideration. And similarly after that we have to create the dead load. So just we can rename it as DL and click on add. And similarly you can go for live load, and under title I can go for LL and click on add and close. So overall, after the seismic analysis, we have to find out the design shear force. Okay, I mean like base shear force. So in order to calculate that, we have to define the loads under these cases. So EQX, just go for seismic loads. This will be open only when the seismic definitions are created. If this is not created, this won't open here. So make sure that you are creating the seismic definition first and then you have to come here. So I want to define the seismic in X direction factor 1. So just click on add and close. Similarly EQZ, just add and you can go for seismic again, seismic loads, and just go for Z direction, click on add and close. So next one, dead load, whatever the dead loads coming on that. So for explanation purpose, I have directly taken the floor loads. Generally we are going to have the wall loads and other loads also. You can consider them too. So here I am just going for floor loads directly, and I want to assign the pressure of -5 here, for example, and the Y range will be starting from 4. We have taken the roof also, so 20 add. And next one, we need to assign the live loads. In definition, we have assigned 50% of the loads, but in live load case, we have to take total pressure coming on the structure. So just go for the floor loads and give the pressure of -6 kilonewton per meter square, which is acting up to the floor levels. So that is starting from 4. This is 16.8. So up to the last floor. And for roof level, we are going to give other value, that is -3 kilonewton per meter square. And the minimum and maximum value will be same. If you want to assign the certain value for each and every floor or particular floor, you have to give the minimum and maximum value as same as of that floor height. So simply after giving these all parameters, click on add and close. You can see that all the loads has been assigned directly. Since floor loads we have given, those will be acting directly on the structure. No need to assign it separately. So before creating the combinations, we'll command the STAAD to calculate the seismic load data. In order to do that, just go for analysis and print here. close this window. Just select the load 2. Okay, if you want to go for if you want to assign the load data for 1, you have to select the next load case and simply click on define commands, and here we are going to have the print. Under print option, just go for load data, and you have to click on after current option. So click on add and then go for change and again add and close. Similarly, just select the load case 3, define commands, load data, after current, add, and simply go for change again and click on add. Make sure that you are keeping after current option and close. So you have to add in between 1 and 2 and similarly 2 and 3. In order to add that one, what we have done, we have to select the load case 2 in order to add between 1 and 2, and similarly in order to add between 2 and 3, we have to select the load case 3. So just come back for the general here, and then you can go for load and definitions. Click on this load case details, click on add, and now you can create the number of combinations there, either manually or you can go for simply auto load combinations. So STAAD calculates for repeated load cases also. So click on add here and close, and then we are going for analysis now. Just go for analysis and print. Either you can go for all or you can keep no print, anything is okay. So just go for analyze now and click on run analysis and save. And one more thing, just I'm going to abort this. Yes, if you want to get the member stresses, member forces for this, simply go for post processing. Yeah, since I have aborted this, there has been error, no problem. Coming back to this analysis print, going for post print, I want to show the member stresses, member forces acting due to this, all the seismic forces and what are the support reactions, etc. For example, just go for define commands here. I want to get the support reactions. Just click on add, and I want to get the member forces, and what are the forces are there. According to that, I want to know the stresses coming on that particular selected members. Okay, so simply you can go for member stresses here and click on add and close. Now we have to assign them for the required members. Print support reaction. So just I'm going to select this first row. From the top view it will be this one. So just going for the node cursor, and you can go for front view and just highlight this one. Only this will be highlighted here. Okay. In case if you want to show this front side, then you can go for the side view and you can activate this one. So support reaction and just assign to selected nodes, assign and yes. And similar way, member forces, I want to get all the forces for all the members of first floor. Just I'm going to highlight this. If you want to get for number of members, you can select randomly also. So you can renumber and you can just select as per your requirement. Assign to selected beams, click on assign and click on yes. Next, member stresses. Again, I want to assign for the same members. So assign to selected beams, assign and yes. So we have added all the print options what we need after the analysis there. So after that we can go for run analysis now. So just it will be asking to save, click on save. And the analysis is being run here. If there is no errors, then you can proceed for the design. So the design steps will be same as you have seen in the previous video. So let us go for the view output file and done. So just go for the results here, click on results, and you can just see the support reactions. Okay, at joint 1, whatever the load cases we have created, at whatever the forces acting in XYZ direction, what is the moments we are going to get there, and member forces. Okay, axial force here in YZ, torsion, moment Y, moment Z. Okay, so here like this we got the stresses, axial stress, bending stress in Y, Z, combined stresses and shear Y and Z. Like this we can calculate. So I want to show the base shear force that has been come due to the seismic loading. So here from the starting in the page number 5 we can see the load data here. Okay, so we have given the earthquake load in x direction. The time period calculated is 0.7 0.0931 seconds as per the code, and SA by G is used to calculate the accelerations, and 1.95 this value. By knowing all these values, we can find out the base shear force. Okay, manually we have to do all the things, but here in the STAAD it will be directly giving the values there. You can see that VB we got 684.73 in X direction. Okay, so for similarly, if you want to go for Z direction, just come down a little bit, scroll down, and you can see for Z direction 2 here. So just let us scroll it more. Or you can just go for Control F, find it for EQZ. Anything is okay here. Let us go for Control F. I'm just going to give EQ and find next. Yeah, we are going to get EQZ otherwise. EQZ and find next. So yeah, we got it here. Loading seismic type, seismic title EQZ. So here also we got almost same only. Let us check with this. So in VB for Z also we got 684.73. Okay. In this way, by using the static analysis, we can find out the base shear force due to the earthquake load or seismic load on the given structure. So this is a simple structure where you can try with the seismic load, and whatever the specifications that has to be given for the structure, you have to define all the loads coming on the structure. And just remember that while defining the load definitions for seismic, you have to take 50% of the live load here. Okay, so in this manner we can do the analysis for seismic in the static analysis method, and after no errors you can proceed for the design. So this is all about the static analysis for seismic design.